we get to use chain rule. The second one, we're going to apply, we're going to do the implicit differentiation. So let's look at the first one. The first one, to get dy dx, we will apply chain rule. So derivative with respect to x, cosine of, there's a quotient in parentheses. So we're going to treat this, okay, as u. And differentiate it with respect to u. And then by chain rule, we know that we're going to have du dx. And u, of course, is going to be replaced by this parentheses right there. Okay, so we can put it on the side. We can put it on the side this way. They're the same. And the next step would just be the derivative of cosine u is going to be negative sine u. Okay, we're going to bring the, u back in a moment. Okay, so that's going to be, we can do that on the next step or this step. All right, so this is going to be negative sine of u, which is, this is our u, right? Multiply, be careful. This piece, okay, is just one entity. The other part cannot combine with this parentheses because this parentheses is the input for sine. Okay, so I'm going to talk about that a little later because we saw some mistakes there. Okay, quotient rule. For quotient rule, we have the denominator here. And that denominator will be squared. Whoops, square outside. And then is and on the numerator, we have the denominator written and the differentiating the numerator. So I'm going to put that in the parentheses. That was in the numerator. And we're going to put a prime. Okay. Subtracting, the numerator stay the same. Multiply, the denominators been differentiated. Okay. Here, I wish to put a little note here. Oh, hold on. This line, I left it empty. So this piece actually should be here. Okay. Now, I want to put a note here because I saw some mistakes when people differentiating derivative with respect to e to the power of 2x. This actually is equals to derivative with respect to v, okay, e to the power of v. V is 2 times x, so this derivative of 2 times x, which is v dx. So the result is that part equals to 2, and this part e to the power v differentiated with respect to v is e to the power of v. But v is 2x. Okay, so I put a note right there because we're going to need it for the next step. Okay, so this one is substituted u in place, and next we're going to keep the denominator. On the numerator, I'm going to copy everything over here, And differentiating this part, the derivative of 1 is 0. The derivative of negative e to the power 2x. The derivative of e to the power 2x is 2 times e to the power 2x. So that part will be replaced by negative 2 times e to the power 2x. It should be in parentheses. Okay, so that's the derivative of this piece is equals to negative 2 e to the power 2x. Oh, hold on. I made a mistake somewhere. Okay, so this one is primed. All right, and that's the prime. Okay, and this piece being differentiated with respect to x, the derivative 1, of course, is 0. E to the power 2x is going to be 2 times e to the power x. So that part will be replaced by 2 times e to the power 2x. This time we don't need a parentheses. This piece we need a parentheses because otherwise, if we don't have the parentheses, it will be viewed as subtracting. Okay, that will be considered a mistake. So this parentheses is necessary. But if you put this piece in the front, right? Suppose I put it in the front, and then you would not need the parentheses. Okay, so either way, okay? And you can also put that piece in the front. It doesn't matter, okay? As long as you know what you're doing, and just to make sure it doesn't cause any confusion. Okay, now what we can do is that there's one term here and there's another one here. You can distribute, combine like terms, but you can also factor out the e to the power 2x from the top. Okay, so I'm going to show you what you get. So I'm going to factor out this piece. Okay, I'm going to factor out this piece and put everything else in the bracket. So e to the power 2x is factored out. E to the power 2x is factored out, right? So inside the bracket, there's multiple ways to do this algebraically. Okay, I'm just using a way that I think most of you may not do. Okay, so just to give you another opportunity to see how algebra can be done. All right, so now, well, actually, we can also factor out the 2. We can also factor out the 2, okay, to make life simple. So we factor out the 2, right? Why not? Just play with it. We want to improve our algebra, right? And then this is negative sign, so negative 1 minus e to the power 2x. So this is a minus, right? And this is a minus 1 minus negative e to the power 2x. So that's going to be minus 1 plus e to the power 2x, right? And you can do this on your scratch paper just to make sure, right? You get it right. And this is a good exercise. Okay, so these two are opposites. So that makes 0. So now we have a negative 2. Negative 2 times negative 2 now is negative 4. All right, so this makes negative 4. Right? And then we're almost there. There's a negative 4 here. There's a negative sign here. Finally, this negative sign will combine with this negative sign. So there's only 4 left. And how do we show our final work? Our final work, it can be like this, or it can also be shown by putting it in front of the sign. This will be probably the most clear. And it's done, it's finished. But I did see a mistake from the quiz, okay? In here, this part, cannot be combined with this. You cannot do this. Okay? Because this sign is only, this parentheses has to be the input for sign. After it comes out, it works, you know, it multiply with the letter of, you know, quotient form. So it's best you put it this way. Best to put it this way. You cannot take this piece, multiply with that to get 1 plus e to the power 2x to the power 3. No, that would be a grave mistake. All right. That was the first question. Second question. Okay, second question. Then, of course, this is the implicit differentiation. Okay. Implicit differentiation. Implicit differentiation here. And what's wanted is that we want dy dx. Okay. And we're going to differentiate on both sides, derivative with respect to x. On the left-hand side, we should insert parentheses, and we're going to differentiate on the right-hand side, so differentiating at the same time. So this should be equal. Sorry about that. And x plus xy, right? You can see if I don't put parentheses, it could cause confusion. It could cause ambiguity, right? So we put parentheses. On the left-hand side is product rule. So product rule, and this will be seen as one function, and this will be seen as another function. So we're going to take a derivative. So how do we write it down properly and clearly? Suppose we work on e to the power y first, right? So we're going to do e to the power y. And we're not differentiating sine x. So it will be good. We put sine x in the front. This will make it the most clear and no ambiguity. The second one, okay, is we're going to keep the e to the power y, multiply the derivative with respect to x on sine x. Okay, so this is clear. On the right-hand side, of course, the derivative of sum. So derivative with respect to x. So that's first part is a derivative on x, right? And the derivative on x times y. So preferably we have a parenthesis so it doesn't cause any confusion. Okay. We can go directly to the next step, skipping this one. So this piece is optional. Okay, but I'm just doing step by step, make sure that we're good. So this is on this piece, we're going to apply chain rule. Okay, so we're going to apply chain rule. So dy and then dy dx. And that part, it is a cosine x. Okay, this piece is 1, and this piece is the product rule. Product rule. So it's going to generate 2 terms. Okay, so generate 2 terms. Differentiating x, so this is 1 times y plus, okay, x multiply and differentiating with respect to x right there. Okay, so by this time, right here, this one is e to the power y. So you can just do it there. All right. This step can be optional, but it's up to you. Next, to clarify and reduce those dots, I would put this piece in the front. So this will cause no confusion And that piece can be written that way. We can remove the bracket. 1 times y is y, and we can remove this dot. Okay, in fact, you can go from this step directly here, skipping these 2 steps, no problem, no problem. And next, we're going to solve for dy dx, okay, by subtracting this piece on both sides. Okay, so we're going to subtract this piece on both sides. Right, subtracting that on both sides. And when we subtract that, and we got, what do we got? We got these 2 will be combined on the left-hand side. So we have dy dx, right? Dy dx. On the inside the parentheses will be e to the power y sine x minus x. On the other side, it's just 1 plus y, right? So that's the effect of subtracting these. So I'm going to remove this, so make it nice and clean later. Okay, later. And we're also going to subtract this guy, right? So we're going to subtract this guy, subtracting this piece, and subtracting that piece on the other side. So this piece subtracted, and over here, this is being subtracted, so it'll come down here. Okay, this work, after you're done, clean it up. Okay, so better do it on the scratch paper. All right, so now dividing both sides by whatever inside the parentheses, which will give us this. Okay, this goes to the numerator, and the parentheses is going to go down to the denominator. And we can remove the parentheses. We're almost done. We're almost done. Actually, it can be considered done, except if you want to do more, okay? Because we can do more. Go back to the original equation. In the original equation, e to the power y times sine x equals to x plus xy. And we can bring that into that equation, e to the power y sine x, right? That part can be replaced by its equal, which is x plus xy. This way, you can see that in the denominator, there's x minus x, right? So x minus x, that makes 0. So in the end, we have this result. This is obviously a little bit simpler, right? In the end, the final answer, which are acceptable, if you get this answer, great, no problem. Okay, you probably get all the credit already. But if you get this answer, that's pretty cool. Okay, that's even better. That's even better. All right, thank you for watching. Goodbye.